Now, from the previous lessons, we learned that work is equals to force multiplied by displacement. And then we also know that force is equals to mass times acceleration. So we can break this down, the force, we can substitute force into mass times acceleration. So we have this formula here. Furthermore, in the previous lessons, we learned about kinematic equation. And we found out that acceleration is equals to final velocity squared minus initial velocity squared over 2d. So we can substitute this value here to this acceleration here. So it turns like this. And then let's simplify this one. So cancel this one, the d. So what's left is this one. And then distribute the mass. And then this one, the divided by 2. This you have to distribute this also. And it turns like this. Okay. And from the discussion about the mechanical energy, specifically the kinetic energy, hopefully you can recognize this one. This formula here is the formula for kinetic energy. The same with this thing. This is the formula of kinetic energy. So we have it here. But since this one, the velocity here is final and the velocity here is the initial. So we have here work is equals to the final kinetic energy minus the initial kinetic energy, or you just simply you say work is equals to the change of the kinetic energy. The equation that we derived a while ago is what we call the work energy theorem. It states that the work done on a body by the net force acting on it is equal to the change in its kinetic energy. Mathematically, it is expressed by this equation. Now let's apply the work energy theorem by answering this problem. A woman pushes a 2 kilogram cart initially at rest with a force of 350 Newton along a horizontal surface. The cart moves a distance of 4.0 meters. What is the final speed of the cart assuming it starts from rest? So again, we have the given. So we have the mass, it's coming from here. And then for the force, that's 350 Newton. Then the distance or displacement, that's 4 meters. Okay, and then we have to include here the initial velocity, which is 0 because it is at rest. Okay, and then let's go to what's being asked. What's being asked is the final speed or the final velocity. Mm-hmm. So what's the formula? So the formula for work energy theorem is this one. Work done is equals to the change of kinetic energy. But we have to break it down so that we could find the formula for final velocity. So how? We have to write it here. Okay. And then we have here the change of work is equals to get the change of kinetic energy. And then you have to break this down. So it turns like this. And then you have to break down also the work because work is equals to force times distance. So we have it here. Okay. Now, to simplify this formula, remember that the initial velocity is 0. So this is the value of the initial velocity, which is 0. So any number multiplied by 0, that will be also 0. So we are going to eliminate this one. So what's being left is this formula. Okay, so how to simplify it more? So what we're going to do is to multiply both sides by 2 so that we could eliminate the fraction. So this is how it looks like. So we have it here, 2 divided by 1 times 1, it's 2fd is equals to 2 divided by 2, that's 1, then times 1. So it becomes like this. Okay, it becomes this one. And then after this, is that you want to have the formula for the final velocity. So what's next is you are going to divide this one by m so that you could eliminate the mass. So what's on the right side? We only have the variable, which is the final velocity, which is the one we are looking for. Okay, so continue. So what we have is that v squared is equals to 2fd. But how are we going to eliminate the squared here? Okay, by putting square at both sides so that we could eliminate the squared here, the square root, and then what's being left is this one. So we have now the formula of the final velocity, which is equals to square root of 2fd over m. Okay, here. So next would be you just simply substitute. So we have here for F, we have the value of F here, that's 350 Newton. And for D, that's the distance, that's 4 meters. And for the mass, that's 2 kilogram. So everything is well and good. Next would be in order for us to understand better how do we get the units of each um, variables. So you have to break this down. For the Newton, it's at kilogram meter per second squared. Okay, so we were done breaking the Newton. So we have to cancel things. So we cancel the kilogram. So let's get our calculator. So what we have here is that 2 times 350, okay, times 4 is equals to 2,800 divided by 2. Okay, but remember there's a square root here, so you have to square root it here. So the answer is 37.41657,387. So we already agree that we have to round off our answer into two decimal place, so this will become 37.42. Okay, but why is it meter per second? So you have to remember, you have to remember that this one is m times m, that's m squared. Okay, so m squared. Then this one over s squared. And then when you square out also this one, the square root of m squared is m, and the square root of s squared is s. So that's why it becomes meter per second. So that's it. Hopefully you learn about work energy theorem.